Welcome back, students. In the last class, we ended with the Riemann Tiemann reaction, which is going to be very important 2-mark question. So in today's class, we are going to discuss another very similar kind of reaction, which is said to be Kolbes reaction. So this is also one of the very important 2-mark question. In your annual examination or in any of the examination, either they will ask Kolbes reaction or Riemann Tiemann reaction, which is going to, one among them is going to surely come. In Kolbes reaction, we are going to convert phenol into salicylic acid. We are going to convert phenol into salicylic acid. So how this reaction works? As usual, we are going to take phenol. Yesterday also, benzene with OH is all the way said to be phenol. For my reference, I'm writing one hydrogen here. This is said to be phenol. Beginning, I'm going to treat with NaOH, that is a base. So here H will be replaced by Na, means this H and this OH both will eliminate in the form of H2O. So you are going to get benzene with ONA and this H as it is. So then what I'm doing, I'm going to treat with carbon dioxide and H+. This H+ will replace this Na, means you are having benzene as it is. On the top your OH will remain. Next what will happen? This CO2 is there. This CO2 will be added in between C and H. Means here it will become COOH. Already H was there. We added CO2. So this is called orthohydroxy benzoic acid. This orthohydroxy benzoic acid is all the way called salicylic acid. So this is how your Kolbes reaction works. So when it comes to explanation of the same reaction, you need to explain or you need to write like, when phenol is treated with CO2 and NaOH followed by hydrolysis, produces salicylic acid. So this is how your reaction works. Then going for the next reaction, we are going to take another very important reaction, that is phenol with sodium dichromate, that is Na2Cr2O7, which is going to be asked for 2 mark. This is almost this year question. Phenol with Na2Cr2O7. I think this question has appeared in this last our annual examination of Karnataka boards. Here, just observe, we are taking phenol, benzene with OH, and we are going to oxidize. This is, I am writing it as a phenol. This I am going to oxidize by using Na2Cr2O7. Sodium dichromate works best in presence of acid like H2SO4. So we are going to get a symmetric diketone, means 6-membered ring will remain as it is. Here 2 double bonds will be opposite to each other, and double bonded oxygen also will be opposite to each other. This molecule is all the way called benzophenone. So means converting phenol into benzophenone is done by using sodium dichromate in presence of H2SO4. So when it comes for the explanation part, you can write explanation as, when phenol is treated with Na2Cr2O7 in presence of concentrated H2SO4, it forms, so important word you have to use here, it forms symmetric diketone. Why the word symmetric diketone is used? Because this is very important word. You see this molecule which is said to be benzophenone, exactly it is same. However you divide the molecule, it is exactly same. C double bond O is opposite to each other, and double bond are also opposite to each other. Such molecule we call it as a symmetric diketone, and that symmetric diketone is called as benzophenone. So this is how your phenol react with Na2Cr2O7. Next we are going for the third reaction and probably last reaction for today's video, students. We are going to take phenol with zinc dust, Zn dust. Zinc dust, a finely powdered zinc in the form of dust. Dust means, already a thin, fine powdered. So here also what we are doing, taking phenol, benzene with OH, we are going to treat zinc in the form of a dust. So slightly we are going to heat it. So you need to observe this Zn and this O. Both will eliminate in the form of zinc oxide, that is ZnO vent. So what is left then? On the head of a 6-membered ring, hydrogen is left. So this is said to be phenol, whereas this is said to be benzene. So you can convert phenol into benzene by using zinc dust. When you write for explanation, I think easily you can make when phenol is treated with zinc dust, it forms benzene. So this will be your explanation, and even this reaction also carries a very important 2-mark question. And one more reaction we are going to cover it up today, that is phenol with, which is again important question, phenol with concentrated HNO3, nitric acid. HNO3 is said to be nitric acid. So how this reaction works? Very simple. We are going to take phenol, again as usual benzene with OH. We are going to treat with, this is I am writing it as a phenol, concentrated HNO3 in presence of concentrated H2SO4, a nitrating mixture. So what will happen? NO2 group, since it is a strong reagent taken, your OH will be as it is here. 3 NO2 groups will come, one at ortho, another at para, another again at ortho position. So you are going to name this like this is 1, 2, 3, 4, 5 and 6. See, your NO2 groups are at second, they are at fourth and they are at sixth. So therefore this can be named as 2, 4, 6. 3 NO2 groups are there, therefore I am writing it as a trinitro, and benzene with OH is all the way called as phenol. So it is called 2,4,6 trinitrophenol, which is commonly called as a picric acid. See, this is how this reaction works, student, and even this is also very important 2-mark question in fact. So again, when you come for the explanation of it, you can write it like when phenol is treated with concentrated HNO3, it forms picric acid. So these are the 4 reactions what we have discussed today. First one was a Kolbes reaction. Second one is a phenol with sodium dichromate where it forms a benzophenone. Phenol with zinc dust where it forms benzene, and phenol with concentrated HNO3 where it forms picric acid. So thank you for watching the video, students. Please subscribe to my channel. Thank you very much.